Oh, probando. Nice. Pues... Musical motion. ¿Qué es lo que hay que hacer hoy? Entonces ya lo practiqué. Me gustaría pensar un poquito.
This course from Harvard University is an introduction to programming using the Python programming language. You will learn how to read and write code, as well as how to test and debug it. This course is taught by Dr. David Malin, and it's designed for students with or without prior programming experience who'd like to learn Python.
Hello world, my name is David Malin, and this is CS50's Introduction to Programming with Python. Whereas CS50 itself is an introduction to the intellectual enterprises of computer science and the arts of programming, this course is specifically focused on programming in Python itself. At the beginning of the course, we'll be focused on a topic in programming known as functions and variables, mechanisms by which you can write code that solves smaller problems, but you can compose those smaller solutions into solutions to larger problems still. We'll then transition to a look at conditionals, a way in code of expressing yourself logically, to maybe do something if some question has an answer of true, or not do something if the answer is false. We'll transition thereafter to introducing you to loops, the ability in code to do something again and again and again some number of times. We'll then transition to something a little more technical known as exceptions. Unfortunately, a lot can go wrong when you're writing code, some of it your fault, some of it perhaps someone else's fault, but you can write code defensively, so to speak, and actually catch those kinds of exceptions, those errors, and handle them properly so that the users you're writing code for don't actually see the same. Thereafter, we'll take a look at libraries, third-party code written by other people often, or perhaps yourself in the past, that you can use and reuse in your own project so as to avoid reinventing the wheel again and again. We'll look thereafter at something called unit tests. It turns out you'll actually write code to test your own code, but you won't have to write tests for your tests. Indeed, this is a best practice in industry, writing tests for your code so that, one, you can be sure that your code today is, hopefully, if your tests are correct itself, but moreover, if you or someone else modifies your code tomorrow or down the line, you can rerun those same tests to ensure that those new changes have not broken anything about your own code. We'll then take a look at something called file I/O for input and output, the ability to not just store information inside of a computer's memory, but rather save it persistently to disk, so to speak, to files and folders. We'll then take a look at another technique known as regular expressions, whereby in Python you can define patterns and you can validate data to make sure the human types something in as you expect. You can use regular expressions to extract data, perhaps from some data set you're trying to analyze. We'll then take a look ultimately at object-oriented programming, a paradigm, a way of writing code whereby you can represent in code real-world entities. And this is in addition to other paradigms of programming that we'll also explore, among them procedural programming, where you write lots of those functions, procedures really top to bottom to solve problems step by step, and even something known as functional programming as well. And then at the very end of the course, we'll equip you with all the more tools for your toolkit, and additional building blocks, additional vocabulary, via which after the same course you can go off on your own and either take other courses or solve projects of your own using all of these mechanisms. Now this course itself assumes no prior programming background, so you don't have to have written a single line of code in Python or any language yet, but this is also a course that you can take before, during, or even after CS50 itself if you'd like to get all the more versed with Python. Each week, via the course's lectures, we'll introduce you to any number of concepts that we'll then drill down more deeply into in the form of problem sets each week. That is, programming projects that will enable you to apply some of those lessons learned to problems of your very own. And by the end of the course, you'll have solved so many problems that ideally are representative of problems you'll eventually encounter in the real world. Whether you aspire to solve code in the technical world, or perhaps in the arts, the humanities, the social sciences, the natural sciences, or beyond, you'll have ultimately the vocabulary and the technical skills via which to approach the same. This then is CS50, and this is CS50's Introduction to Programming with Python. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on functions and variables. But odds are most of you have never actually programmed before, so let's start by doing just that. Let me go ahead here and open up my computer, and on it a program called Visual Studio Code, or VS Code, which is just a very popular program nowadays for actually writing code. Now, you don't have to write code using this particular tool. In fact, all you need at the end of the day is a so-called text editor, a program for writing text. And heck, if you really want, you could even use something like Google Docs or Microsoft Word. You'd have to save it in the right format, but really at the end of the day, all you need is a program for writing text, because that's what code is, text. Now, within this particular program, I'm going to have the ability to create one or more files via this top portion of the screen. And I'm going to do so by diving right in and doing this at the bottom of my screen. At the bottom of my screen is a so-called terminal window, and this is a command line interface, or CLI interface, to the underlying computer, be it your Mac or your PC, or even some server in the cloud. And what I'm going to do here is literally write code, and then the name of the file that I want to code, for instance, hello.py. As we'll soon see, any program that you write in Python generally has a file name that ends in .py to indicate to the computer that it's indeed a program written in Python. Now you'll see here at the top of my screen I have a blinking cursor, a line 1, which is where the very first line of my code is going to go, and then just a tab that reminds me of the name of this file, hello.py. And without even knowing much Python, I'm going to write my very first program here as follows. Print, open parenthesis, quote, hello, comma, world, close quote, and close parenthesis. And you'll see that at my keyboard, some of my thoughts were finished for me. I only had to type one parenthesis and the other one automatically appeared, and that's just a feature that we'll see of tools like this tool here. Now, even if you've never programmed before, odds are you can guess, infer what this simple program is going to do. And it's only one line. Print, open parenthesis, quote, hello world, close quote, close parenthesis. Indeed, when I run this program, ultimately it's just going to say hello to the world. And in fact, this is very famous. Perhaps the most canonical program you can write as your very first program in Python or any other language, and so that's what I've done here. But on my Mac, my PC, even my phone, I'm generally in the habit, like you, of running programs by double-clicking an icon or just tapping on the screen. But I see no such icons here. And in fact, that's because my interface to at least my current Mac or PC or some server in the cloud is again only a CLI, command line interface, which even though it might feel like it's a step back from the menus and buttons and icons that you and I take for granted every day, you'll find we think that it's ultimately a much more powerful interface and incredibly popular to use among programmers in the real world. So to run this program, I'm going to have to use a command. And I'm going to move my cursor back down to the bottom of the screen here, where previously I already ran one command, the command code, which has the effect of opening VS Code in my computer, and then I passed in the name of the file that I wanted to code up. Now I have a chance to type a second command, and you'll see I see a second $sign. Now the $sign here doesn't indicate any kind of currency or money. It just is the symbol that's generally used to indicate your prompt, where the command line interface wants you to put those commands. Now the command I can run here is going to be this. I'm going to run python of hello.py. Now why is that? Well, it turns out that when I actually write code in a language like Python, it's of course stored in that file, hello.py, but I need to interpret the code top to bottom, left to right, so that the computer knows what to do. And see, at the end of the day, even if you don't really know much about computers, you've probably heard that computers only understand zeros and ones, the so-called binary system. Well, if that's the case, then something that says print and parenthesis and quote-unquote hello world is not surely zeros and ones. We have to somehow translate it into the zeros and ones that the computer understands. Now, fortunately, so long as you've installed such a program in advance, there's a program as well as a language called Python. So Python is not only a language in which we're going to write code, it's also a program, otherwise known as an interpreter, that you install for free on your own Mac or PC or some server in the cloud, and you can then run that program, that interpreter, passing to it as input the name of your file, like mine here, hello.py, and then that program, that interpreter, will handle the process of reading it top to bottom, left to right, and translating it effectively into those zeros and ones that the computer can understand. So let's do just that. Let me go back to VS Code here. I already typed out python of hello.py, but I didn't yet hit enter, and that's what's now going to kick off this command. And hopefully, if I didn't mess any of this up, I should see my very first program's output to the screen. And voila, hello world. So if you too have typed exactly that same code and have executed exactly that same command, you will have written your very first program, in this case, in Python. Well, now let's take a step back and consider what is it that we actually just did, and what is it we're looking here on the screen. Well, first and foremost, in most any programming language, you tend to have access to what are called functions. A function is like an action or a verb that lets you do something in the program. And generally speaking, any language comes with some predetermined set of functions, some very basic actions or verbs that the computer will already know how to do for you, that the language really will know how to do for you, and you, the programmer, the human, can use those functions at will to get the computer to do those things. Now, the program in question here, hello.py, is using one function. And you can perhaps guess what it is. That function is, of course, going to be this function print. And that print function, of course, doesn't print some preordained string of text. That is to say, it prints whatever. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on functions and variables. But odds are many of you, most of you, have never actually programmed before, so let's start by doing just that. Let me go ahead here and open up my computer, where the very first line of my code is going to go. Back down to the file that I've in advance with float fundamentals. So functions at will to get the computer wants it to print. And here, too, we have another piece of terminology in the world of programming, namely arguments. An argument is an input to a function that somehow influences its behavior. The people who invented Python, of course, didn't necessarily know what it is you and I are going to want to print to the screen, so they designed this print function using these parentheses with the ability to take as input some string of text, be it in English or any other human language, that is what you want this function ultimately to print onto the screen. And what is it that the program's ultimately doing on the screen? Well, it's printing, of course. It's showing us hello world on the screen, and that's generally in programming known as a side effect. It can be visual, it can be audio. In this case, it's something that appears on the screen, and functions, therefore, can indeed have these side effects. One of the things they can do as this verb or action is to display on the screen as a side effect something like those words that we wanted, hello world. So that's my first program, and I'm feeling pretty good. Everything worked as planned. I didn't make any mistakes, but honestly, when you're learning how to program, and even once you've learned how to program years later, you're going to make mistakes. And those mistakes, of course, are referred to a term you might already know, which is that of a bug. A bug is a mistake in a program, and they can take so many forms, and take comfort, perhaps, in knowing that over the coming weeks, you're going to make so many mistakes. You're going to have so many bugs in your code, just like I did, and just as I still do, and those bugs themselves are just mistakes that are problems for you to solve. And over the weeks to come, we're going to give you a lot of tools, both mental and technical, via which you can solve those problems, but just don't get discouraged. If when writing your program for the first time, it doesn't even work that first time, it will, with time, with practice, and with experience. So let me deliberately now make a mistake that there was a non-zero chance I might have done accidentally already, but I got lucky. Let me go ahead and just suppose I forgot to include something like the closing parenthesis at the end of this line of code. The code is almost correct. It's like 99% of the way there, but now that I've pointed it out, it's pretty obvious that it's missing that closed parenthesis, but even little, seemingly minor details like that you and I as humans wouldn't really care about. And if you're sending an email or a text message, whatever, it's just a typo. It's not that big a deal. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on ask questions, admittedly mathematical questions, but we'll start there if only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. The second symbol problem, but it kind of left us in a bit of a bind, because how do we now compare two things left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, L if x greater than y, L if. Notice that it's having here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who've been programming for years might not necessarily be in the best habit of indenting your code properly, and one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here, and indeed it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks and All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on Object-Oriented Programming, or OOP. It turns out that in the world of programming, there's different paradigms of programming languages. There's different ways of solving problems with code, and it's a little hard to see this at first if you've only learned one language, but over time, if and when you learn other languages besides Python, you'll start to notice certain patterns and certain capabilities of some languages, but not another. Thus far, within the world of Python, you and I have largely been writing code that's procedural in nature, whereby we're writing procedures, we're writing functions, and we're sort of doing things top to bottom. Everything is step by step by step, as you would expect in general from an algorithm. But along the way, we've actually dabbled in another paradigm known as functional programming with Python, whereby we've been able to pass functions around. We even had an anonymous function some weeks ago, and that's evidence of features of a functional programming language, even though we've just scratched the surface thereof. Today, we focus on another paradigm, and this one in more detail, namely object-oriented programming. And now, while some of you might have prior programming experience and have learned languages like Java, which are by design fundamentally object-oriented, Python indeed allows you a bit of flexibility when it comes to how you solve problems with code. But it turns out, OOP, object-oriented programming, is a pretty compelling solution to problems that you invariably encounter as your programs get longer, larger, and more complicated. So indeed, OOP for our purposes is going to be a solution to a problem that builds on so many of the lessons past. So let's go ahead and do this. Let's start by writing a program very procedurally by opening up VS Code here. I'm going to go ahead and create a program called student.py. And in this program, I want to do something relatively simple initially, as we might have done some weeks ago now, where I just ask a user for their name and maybe in the context of the Harry Potter universe, their house, and just print out where that student is from. And let's gradually enhance this program by adding more and more features to it and see if we don't stumble upon problems that up until now we might not have had very elegant, well-designed solutions to. But if we introduce explicitly object-oriented programming as a programming technique, I bet we can clean up our code and set the stage for writing even more sophisticated programs, longer programs down the line. So in student.py, let me go ahead and do a name variable, setting it equal to the return value of input, and just prompt the user for their name like this. And then let me go ahead and do the same for a house variable and prompt the user for their house using input like this. And let's do something super simple now. Let's just go ahead and print out an F string that says something like name from house, just so that I can confirm that the contents of these variables are indeed as I expect. I'm not going to do any error checking or trimming or anything like that for now. I'm really just going to spit back out whatever the user just typed in. All right, let me go ahead and run Python of student.py. Let's use our goto, like Harry, as in Harry Potter, from Gryffindor. And when I hit enter now, let's see if I see that Harry from Gryffindor is indeed the case. All right, so I think we have a working program at this point. But let's now introduce some of those lessons learned way back from week 0, where we started writing our own functions. Not necessarily because it solves the problem more correctly. I dare say this is correct as is, but it begins to give us building blocks that we can extend so as to solve more complicated programs. So let me go back up to student.py, and let's go ahead now and do this. Let's put the entire logic I just wrote inside of our typical method called main, and let me indent those 3 lines so that at least they're now combined into one main method. But instead of using input on line 2 and input on line 3, why don't we go ahead and assume for the moment that we've got some function called getName in the world, and let's go ahead and assume we've got another function like getHouse in the world that don't take parameters, but their purpose in life is, by their name, going to be to get the user's name and to get their user's house respectively. And then I'm going to print out the exact same F string as before. I, of course, need to implement these functions now, so let me go lower in my file and define a function called get_name, nothing in these parentheses because it's not going to take a parameter, and I'm going to go ahead and do something like name equals input, quote-unquote name, just like before, and then I'm going to go ahead and return name. So it's a super simple function, but it's an abstraction. I now have a function called getName whose implementation details I don't have to care about anymore. I just know that the function exists. And I can tighten this up, in fact. I don't really need a name variable on line 8 if I'm immediately going to return that same name variable on line 9. So let me just tighten this up a little bit, even though it doesn't change the functionality, and just immediately return the return value of the inputs function call here. Let's do something very similar now for getHouse, which will similarly take no arguments. I'm going to go ahead and return the return value of input, this time prompting the user for their house. And I need one final detail at the very bottom. Let's continue our habit of doing if the name of this file equals quote-unquote main, then let's go ahead and actually call main. And recall that we have that in place so that if this eventually becomes part of a module, a library of sorts, I don't accidentally call main blindly. I only do it if I mean to run main from the command line on this file. All right, so if I didn't make any mistakes here, let me go ahead and in my terminal window again run Python of student.py, enter. Let's type in Harry, enter. Let's type in Gryffindor, enter. And we're set. Harry from Gryffindor seems to still be working. So we haven't really solved the problem any more correctly, but I've laid the foundation to maybe now do some more interesting things because I've got these building blocks in place. All right, but let me propose that we could be doing this a little bit differently. Get name, get house is fine, but at the end of the day, I'm really trying to get a student from the user. I want their name and their house, not just one or the other. So maybe it would be a little cleaner still to define a function called getStudent and let getStudent do all of this work for us. Now, theoretically, getStudent could call getName and could call getHouse, but because these functions are so short, I think I'm okay with just defining one function called getStudent that similarly won't take any argument, but it's going to do 2 things. It's going to get the student's name by prompting them with input as before, and it's going to get the student's house by also prompting them as before. And then, now, I want to return the student, but I think I might have painted myself into a corner here because I now have two variables, name and house, and yet up until now, we pretty much returned one or the other. We've returned one value. So any suggestions for how we can perhaps solve this problem that I just created for myself, whereby I want to return really a student, but I currently have a name variable and a house variable? I'd minimally like to return both of those.
I believe that we can return a dictionary include the name and the house.
Yeah, so we absolutely could return a dictionary, a dict object in Python, whereby maybe one key is name, one key is house, and the values thereof are exactly the values of these variables. So we could totally do that. I worry that might be getting a little complicated. I wonder if there's a simpler way instead. Any other instincts, even if you're not sure it would work?
Return both name and house.
Return both name and house. I like the sound of that. It sounds simple. I don't have to figure out what a dictionary is going to look like. And in fact, this too would be a valid approach, even if you've not seen this before. It turns out in Python that you can kind of return multiple values, but that's a bit of a white lie. Or we can take Mohammed's approach of actually returning a dictionary and putting multiple keys therein. So here again, we have yet another example of how you can solve the same problem in at least two ways, and I dare say we're about to see even more. So one way you could solve this problem, whereby you want to return multiple values, would be to do something like this. I could go ahead and literally return not just name, but I could put a comma and also return house. This is not necessarily something you can do in other languages if you have programmed in other languages before. It depends on the language, but it looks like, thanks to this comma, maybe I can in fact return two values as actually proposed. Well, if I'm returning two values in this way on line 10, how do I get both values at the same time? Well, there's a couple of ways. Let me go up to my main function. I know minimally I'm going to have to change the get name and get house to get student, but what am I going to store the return value in? I think I could actually do this. And we have seen this technique before, where you can unpack, so to speak, sequences of values that are coming back. And indeed, consider this to be exactly that. Name, comma, house is some kind of sequence that I'm returning of values. Name, comma, house. So if I want to unpack those and store the return values in two separate variables, I can in fact use the commas on the left-hand side of my assignment operator, the equal sign, to do just that. Now to be clear, I don't need to call these variables name and house here. I could simplify this and use just n here and h here, and then I could return just n and h, but I would argue that's not very clear to the reader as to what's going on. So I think in this case, even though it's a coincidence that I've used the same variable names in get student and get main, in main, it's a little more readable to someone like me, so I'm going to leave it as is. Well, let's go ahead and see now if this works. Let me clear my screen down here. I'm on Python of student.py, enter. Let's again type in Harry. Let's again type in Gryffindor, enter, and voila, we still see that Harry is from Gryffindor. But what are we actually doing here? What are we actually doing by returning this value? Well, it turns out that what we've just done is used a tuple. A tuple is another type of data in Python that's a collection of values, x, comma, y, or x, comma, y, comma, z. It's similar in spirit to a list in that sense, but it's immutable. It's not mutable. Now, what does that mean? A list, as we've seen it before, is a data structure in Python that you can change the values of. You can go into bracket 0 for the first location and change the value there. You can go to bracket 1, bracket 2, bracket 3, and actually change the values in lists. But if you have no intention of changing the values of variables and you want to return effectively multiple values, you don't have to even return it as a list. You can return it as a tuple instead, just by using a comma. And it turns out we can make explicit that, here's the white lie, I'm not actually returning two values per se. Whenever you use a comma in this way on line 9, you're actually returning one value, which is a tuple. Inside of that tuple now are two values. So it's similar in spirit to returning one list with two things. Here I'm returning one tuple with two things. And the mere fact that I've used a comma and nothing.
Python está fácil. Ahora la pregunta es qué puedo hacer con Python. estar haciendo esto.
Have you ever dreamed of creating your own video game but thought it was too hard, too expensive, or too impossible? What if I told you that right now, today, you can start making your first game without knowing how to code, without spending a fortune, and without waiting years to learn the skills? Hi, if you're new here, I'm Rafał Bremski, and I've been a know how to program or create assets like 3D models or 2D art to start making games. Today, the barrier to entry for creating games is lower than ever. Tools like Unreal Engine, Unity, and Godot, along with various asset creation tools, enable complete beginners to dive into game development without spending years learning programming or obtaining a degree in art or design. If you're aiming to work for a game development studio, a university degree might seem helpful, but is often not required. Throughout my career, I've never encountered a situation where a degree was mandatory to apply for a job. For those interested in studio positions, I've created a separate video on my channel that you can check out after this one. Many topics I'll discuss here can also enhance your prospects of working in a company, as solo game development helps build a personal portfolio, which is the best way to break into the industry. Before diving into creating your game, you need to decide on the platform you're targeting. For your first solo project, releasing on Steam or mobile platforms is generally the best idea. While developing for consoles like the recently announced Switch 2 is an option, it involves a lengthy application process and acquiring specific hardware called dev kits for testing. Defining your platform early is crucial, as it will influence game design, especially regarding user input. Playing with a controller or mouse and keyboard makes for completely different experience, as well as using touchscreen is completely different experience to those two. Once you have chosen your platform, decide on the type of game you want to create. This can sometimes be trickier than you might think. New developers often design games that are fun to make rather than fun to play. I made the same mistake when I was starting out with some of my mobile projects. For example, one of the games I made was a Christmas Factory, an idle game in which you manage a toy-making factory, employ new elves, and manage the toys production pipeline. This was a game that was very entertaining to make. Thinking of how to implement a system for managing AI systems for my elf workers was something that gave me a lot of fun. It was a puzzle for me as a developer, but turned out to be not so fun to play when I eventually released the game. Me as a developer had all the fun with not much entertainment left for the players, and that led to very poor reception and low sales of the game. In my other project, Starway Deadly Atmosphere, I took a different approach. I analyzed popular mobile games and incorporated engaging mechanics suited for mobile devices. Once I knew what things players like, I used it as a main design mechanic in my game. This time I still had a ton of fun making the game, but that flipped my thinking upside down and taught me that when thinking of a new project, you should always start with what your end user will like to play. Start with the player, not with what you want to do as a developer. Another important aspect when thinking of a project you want to make is market saturation. From a business perspective, there are two main strategies: red ocean and blue ocean. Red ocean refers to markets crowded with similar games, competing for an already established audience.
Here is how to download and install Aspirite completely for free. You're allowed to do it because we're following a guide from the official Aspirite GitHub page. We only need to download and install 5 things and just run 3 commands. The process will take at most 30 minutes. Links to the guide and everything else that I mentioned is in the description. First download the Aspirite source code, ignore this beta version and pick the full release by going to Assets and clicking the first link. Then go to your full release by going to Assets and clicking the first link. Then go to your C drive and create this Aspirite folder. Extract the files from the zip file you downloaded into the Aspirite folder. Next, download CMake, scroll down to latest releases and pick Windows x64 installer. Go through the installation process. Here be sure this is checked so CMake is added to the path environment variable so that it can be used in a terminal. Next, download Ninja. Download ninja-windows.zip. Inside the zip there is a single executable file called Ninja. Back in the C drive create a folder Ninja and inside the zip for install. So here be sure this is checked so CMake is added to the path environment variable so that it can be used in a terminal. Next, download Ninja. Download ninja-windows.zip. Inside the zip there is a single executable file called Ninja. Back in the C drive create a folder Ninja and inside it extract the Ninja executable file. Next we need to download Skia. This release is only for Aspirite beta, so we need to install the one below that. This is for the official release. Download Skia Windows release x64 zip. Now once again, next we need to download Skia. This release is only for Aspirite beta, so we need to install the one below that. This is for the official release. Download Skia Windows release x64 zip. Now once again in C drive create deps folder, which is DEPS. Inside it create Skia folder and inside a single executable file called Ninja. Back in the C drive create a folder Ninja and inside it extract the Ninja executable file. Next we need to .zip. Inside the zip there is a single executable file called Ninja. Back in the C drive create a folder Ninja and inside it extract the Ninja executable file. Next we need to download Skia. This release is only for Aspirite beta, so we need to install the one below that. This is for the official release. Download Skia Windows release x64 zip. Now once again in C drive create deps folder, which is DEPS. Inside it create Skia folder and inside that folder extract the contents from the zip inside the Skia folder. Zip inside the Skia folder. Now we need to edit the environment variables. in Windows search type environment and you will see edit system environment variables. Click on environment variable. Click on environment variable and you will see edit system environment variables. Click on environment variables. For user variables, go to path and edit it. Click this new button and type here C drive Ninja. Then OK. Next, install Visual Studio Community. OK. Ninja. Click this new pulse, go to path and edit it. Click this new button and type here C drive Ninja. Then OK. Next, install Visual Studio Community. If you already have Visual Studio, type installer and you should see Visual Studio. If you already have Visual drive Ninja. Type here C drive Ninja. Then OK. Next, install Visual Studio Community. If you already have Visual Studio, type installer and you should see Visual Studio installer. I already have Visual Studio Community, so I'll hit modify. If you're installing it for the first time, you will also see something like this. Scroll down to game development with C++ and check it. And make sure you check Windows 10
Te voy a cambiar el nombre.
SDK, but you check Windows 10 SDK, particularly the first one, which ends at 1836.2. We picked that because the guide says to install exactly that SDK, and then just install. Skia needs to be in the deps folder in the C drive because the command we use later on expects Skia to be there. Now in your C drive, in your Aspirite folder, create a new folder called build, open it, click here and type cmd. This will open a command prompt. Click here, folder called build. Open it, click here and type cmd. This will open a command prompt inside the build folder. Copy this line from the open a folder called build, open it, click here and type cmd. This will open a command prompt inside the build folder. Copy this line from the